So, hello everyone. I hope you are doing well in your home. Welcome to Edu Global Institute. I am Rohan Kumar Singh, the founder of Edu Global Institute, basically. So, we are going to start this basic mathematics series, and this is helpful for all the students who are planning to attempt AMC 8, AMC 10, AMC 12, and any mathematics Olympiad and contest, national and international level, basically. Okay, first of all, I will introduce myself Rohan, and I am the IIT Madras alumni. I have like won, I'm the gold medalist in maths and physics Olympiad, and one of the most important thing, from the last 6 years, I'm regularly teaching the national international level students for maths, physics, and for research also. So the most important thing why we are starting this basic mathematics series, many of the people get confused because when I have seen a lot of students are facing problems in doing the basic maths. They don't even understand what is mathematics and why we are studying these XYZ type of topics. So that's why we have taken an initiation such that each and every student should know the basics, the depth of each topic. So that's why. So in our episode 1, the topic what we are going to start today is HCF and LCM. I know most of you are familiar with HCF and LCM, but we are not going to talk about any simple things and any easy things here. Okay, we are going to go deep down inside it. We are going to talk about each and every fact and every single thing. So the topic is HCF and LCM. Okay, so now the point is, what is HCF, what is LCM, why we are using, okay, and is there any realistic approach for HCF and LCM, what are the application? And one of the important thing I will just let you know that in AMC 8, okay, in AMC 8 it is one of the most appropriate topic that there is one of the topic that is known as modular arithmetic. Okay, so if I believe that if the student have a good approach, good idea how to solve, how to apply the logistics in the HCF and LCM, they can easily replace modular arithmetic for only AMC 8, not AMC 10 and 12, because at that case model we usually work with the advanced level of concept in modular arithmetic basically. But for AMC 8, student don't need to study about modular arithmetic. So the first thing is in HCF and LCM. So we are going to start. Let's start. So what is HCF? What is HCF? Now here it starts basically. What is HCF? HCF is, if I will just ask what HCF, it's the highest common factor. It's the highest common factor. When I'm talking about common factor, I believe that most of the student know very basics like factor, multiple, these stuffs. Okay, that's why we directly started what is HCF from HCF directly. Okay, so I believe that all of you know about the common factor. Just giving a short idea, like let's say I have a number 8, so I will figure out all the factors first of all. That is 1, 2, 4, and 8, and another one is 12. 1, 2, 3, 4, 6, and 12 basically. So so first of all I'm going to figure out the common factor. These are the factors of 8 and 12. These are the factors. So now I'm going to figure out the common factor basically. So what is common factor? What is common factor? Common factor are 2, 4 basically. Okay, and among like them, the highest common factor is the is 4 basically. So we say like we call HC, that is HCF. Okay, that is 4, and that's why it's called the HCF, highest one. And among the common factors, which one is the highest, that is known as greatest, you can say. So that's why HCF is also known as GCF, and it's also known as GCD. So yeah, you can say like HCF, GCF, GCD are all similar to each other. There is no any difference. Also, like GCD, most of the student can confuse, sir, what is GCD and how you can relate HCF and GCD. Wait a minute. Look, GCD is greatest common divisor. That means a number, let's say if I will figure out GCD of two numbers, Okay, so the number that I got, if I will divide those two numbers, so it's very obvious that it will not get divided further. So again I will say for 8 and 12 the GCD should be 4. Okay, as I told you, GCD and HCF is same completely. So GCD is 4. When GCD is 4, so I will say if I will divide 8 by 4 and 12 by 4, the resultant should be 2 and 3. Okay, when it is 2 and 3, so I believe no one can divide it further. Okay, I just want the answer in the natural number, in the natural number, not any decimal representation, not any fractional representation, just a natural number I want as the answer. So the fact is here. So when I'm going to divide the greatest factor or greatest divisor, okay, common divisor, and from those common divisor, whatever the greatest common divisor, so after that it's nothing. Now where it's very important thing comes, sir, what happened, let's say we have A and B, okay, two numbers. We have two numbers. A and B, we have two numbers basically, okay, and these two numbers having HCF as C basically, okay. So if I will divide, okay, HCF of A and B is C, HCF of A and B is C. So in that case, when I'm going to divide A and B by C, so the resultant is resultant must be co-prime. Now it comes, most of the student get confused. So what is co-prime? So look, co-prime is a pair of numbers having HCF 1 only. Pair of numbers having HCF as 1. Okay, the point is I have some numbers. Okay, let's say I will take 2 and 3. So the HCF of 2 and 3 is 1. I will say 8 and 9. Okay, the HCF is 1. I will say 9 and 10. The HCF is 1. I will say 12 and 19. The HCF is 1. So these are co-primes. So when I'm comparing two numbers or three numbers might be, okay, so in that case, if the HCF is 1, HCF, the combined HCF, okay, the combined HCF, not for any two, not for any three, like whatever the number group we have, if all of the combinedly we have the HCF as 1, then we can say, yeah, that's a co-prime basically. So yeah, now look, why we are studying this point, okay, let's say I will take any example, let's take some random example. uh you know that, let's say A and B are two numbers, okay, okay, and whose HCF is whose HCF is C. So prove that the numbers when divided by C, numbers when divided by C, we got coprime. We got coprime. Now look at this. Look at this. A and B are two prime numbers. Okay, two numbers only, not a prime, not anything. It's just a two numbers. So the HCF is 1. That means the maximum factor, the greatest factor of A and B is C. So A can be written as C times X, and B can be written as C times Y. Is that okay? That's why the HCF is That's why the HCF is C. But after dividing A and B by the HCF, A and B by the HCF, in that case we got X and Y as the resultant. X and Y as the resultant. So we can directly say that yes, for X and Y, like, so X and Y, I got X and Y. Okay. Now think about, C is the highest divisor which can divide A and B. Okay, because I'm comparing A and B, not any other third number or fourth number. I'm comparing only A and B, and C is the greatest divisor which can divide A and B simultaneously. So that means X and Y we got are individually prime. Think about this. Individually prime, or or X and Y should be co-prime. Let's say, let's contradict that. Let's say X and Y are not co-prime, are not co-prime. Then it's very obvious that X and Y having one more common factor. I will say it having one more common factor as P. That means X may, X is the multiple of, like, P. The multiple of P should be X, and the multiple of one of the multiple of P is also Y. So in that case I can directly say that yes, the resultant is completely, uh, like, so the C is not the greatest HCF we have, because after that we have also P there. After that we have also P there. So the HCF should be C times P. Let's take an example. Let's take a real example. Okay, 30 and 46. These two numbers I'm taking, not these two. 36 I'm taking. Okay, now 30. All common factors should be 1, 2, 3, 5, 6, 10, 15, and then 30. For 36, 1, 2, 3, 4, 5, 6, 10, 12, 13, and 18, and then 36. Okay, now what are the common factors? It's 1, 2, 3, 6. Yeah, 1, 2, 3, and 6. Among them, the HCF should be 6. When the HCF should be 6, I'm going to divide 30 and 36 by 6. I got 5 and 6. I got 5 and 6. Now the point behind this is, because 5 and 6 are the numbers, 5 and 6 are the numbers. So in that case I can say that directly is, it's like, now figure out the HCF of 5 and 6. It is 1. It is 1. We can say it's a co-prime. So whenever the HCF is divided by the numbers, the resultant should be co-prime. It's always a co-prime. Let's say, my bad, my mistake. I forgot a number. I forgot to choose the number 6. I chose HCF as 3. Am I right? HCF as 3 I chosen, because I haven't calculated it perfectly. I forgot it. Okay. So in that case, what I have done basically, so I will divide 30 by 3, it's 10. 36 divided by 3, it should be 12. Understood? Now we know that they having one more common factor, that is 2, because 10 and 12 still divisible by 2. So now 2. So 2 5s are 10 and 2 6 are 12. I got. Now they are individually, now we can say they are co-prime. So until unless we didn't get the co-prime, we are not going to stop. Okay, we want the highest common factor. And somehow if you don't understand or you miss this type of things, so what you need to do further, they are divided by 2. I will multiply 3 and 2, that is 6. That is the HCF basically. Okay, so this is how the HCF is. So so the HCF is divided by the numbers. The resultant is always what? It should be co-prime. Okay, now uh like just giving you another method to figure out the HCF, because what happens, let's say I will write down 1537. Okay, so let's say if you're going to figure out the HCF, first you need to figure out the like factors, then you're going to do next step common factor, then HCF. But to figure out the HCF of this number, it will be complicated. Why? Because I know that to figure out the different like common factors, or not only the common factors, the common factors basically, I know that it will be very complicated type, because I need to check from 1 to like 153 till 1537, so that they are divisible. Okay, some of the students know the trick, but sometimes what I think, to understand or to learn the trick, okay, it's sometimes waste of time. Okay, because mathematics or any topic in the mathematics have given some another law, another way through which we can adjust it. So now I have 1537. I have, so let's say I will take two numbers, a and b. So I will figure out the HCF by division method. Division method. What's that division method? Let's say, first of all, I am going to look at that which among between A and B, which is the smaller. So A is smaller than B, which is A is smaller than B. So if I will divide A by B, so after dividing I will got the remainder as C, suppose. So now if I got the remainder C, then the divisor become the dividend of the next one. Again if I will got D, then again the divisor got the dividend. If I will got E, again the divisor got divided. This process will be repeated until I got remainder as 0. Until remainder as 0. Let's take an example. 1017 and 1537. I don't know is the from which number these are divisible or not. So first of all I will check uh, is which is smaller. This one is smaller, so dividend should be 1537, and I got 1017 basically. Okay, now divide 1017, 0 2 5, 1017. So it's again 1 520 7 9 954, then 520 1 4 9 7 3 2. Okay, then 23 I will go for divide division, 497. I will check the remainder. So 23 2s are 46, 3 7, 23 1s are 23, it's 1 4 14. So 14 23, because most of the student will understand that they are very contradicting to each other, because one of them is 14, other one is 13. So anyhow I can't figure out the factor. Let's take 14 ones are 14, it's 9 14 1 5. No, it's not possible. The HCF should be 1. HCF should be 1. HCF should be one of them. Okay, so so I can say that 1017 and 1537 are co-prime. So I think it is one of the most finest and easiest way to figure out the HCF. I know whether it take a time to divide, but the point is I will never forget any single number, because if I will just go with the factorization, I will factorize it, so it will take a lot of time, because I need to check from which number they both are divisible, and then I'm going to move further my process. So that's the point. So I will prefer that, most of the student use divisibility rule. It is efficient, it will give the time, it will save our time, it will give the answer perfectly, and moreover the things is okay. Now moving to the next topic, that is LCM. Okay, LCM. What is LCM? LCM, everybody knows, it is lowest common multiple. Lowest common multiple. What about lowest common multiple? Like, among first of all, I have two numbers or three numbers, whatever we have. So first of all, I will write down all the multiples. Okay, when I will write down all the multiples, I am pretty sure that among all those multiple, which one is the lowest. And sometimes LCM is also known as FCM. Now most of the student will, okay sir, what's the GCF? HCF is also known as GCF, GCD, but LCM is as FCM. It's like first common multiple. That's why the point is, okay, the point is FCM, LCM also written as FCM. Okay, let's say 6 and 8. So 6, I will write down all the multiples. 6 1 is 6, 12, 18, 24, 30, 36, 8. So it's like 8, 16, and then okay. I will got the first multiple right now, that is 24, and I will say LCM is 24. Most of you people figure out the LCM by 6 and 8. 2 3s are 6, 2 4s are 8. So now it was not divisible, so I will write down 2 times 3 times 4, that is 12, 2s are 24. That's it, I got the LCM as 24. So I think, like, yeah, it's good, it's perfect to being ordered and perfectly manageable. Now LCM is what? LCM is what? Because let's say we have two numbers A and B. The HCF is C basically. I have written down A should be C times X and B should be C times Y, where X and Y are co-prime. This is mentionable, co-prime. So when I will write down LCM, so it's C times X times Y. Okay, so I can write down HCF times X times Y. That is the LCM. Now remember that. Let's say you will get any two numbers and you need to figure out the LCM, and you don't know from which number it should be divisible first, because in this case also I need to check from which which first number it is divisible. Okay, so here it is 2. Okay, here it is 2, but the condition is from whom it is divisible when I'm considering X and Y. Okay, so LCM, that is equal to HCF times X and Y, X times Y basically. Okay, now listen it very carefully. LCM is HCF times X times Y. Okay, okay. It is a rule that to figure out the LCM and HCF is perfect or not. Okay, LCM and HCF is perfect or not. So remember that LCM is divisible by HCF. LCM is divisible by HCF. This is the rule. LCM is divisible by HCF. So this is one of the fact. From the starting, I'm writing down more facts and more reasonable things. Okay, in any of the contest, nothing will ask more than this what I'm going to teach here. So don't worry about your preparation. Just do it, copy it what I'm teaching. Okay, and any one of you wants one-on-one personal tutoring with me from me, so you can contact, you can go to eduglobalinstitute.com. Okay, and then you can just fill up a Google form, as well as I will just put the Google form in the like description also. You can visit, you can check, and you can let me know what's the possible. Okay, what's the possibility. Yeah, so LCM is divisible by HCF. The point is here, LCM is divisible by HCF. Now here comes one of the fact is, let's say A and B are two numbers. So I will write down A times B. It is equal to HCF times LCM. Remember that. LCM times HCF. Remember that. Okay, that is important. That is important. Yes, it's done now. It's done. Now let's take some questions. Okay, because without doing the question we are not able to understand what is inside this. Okay, so that's why I have prepared a question sheet also, so you can just hmm. So I know everybody can do this, do figure out the HCF and LCM, but the main problem is when it comes to the word problem, most of the student face bit issues. Okay, so let's take one of the easiest problem, then we will take one by one. So yes, the first problem is this: three bells tall at three bells tall at 12 minutes, 15 minutes, and 18 minutes respectively intervals of. So let's say there is a first bell, it ring at the first. After 12 minutes it ring again. After 12 minutes it ring again. The second bell, it rings first, then 15 minutes, then again 15 minutes, then again 15. Similarly, 18 minutes. If they first toll together at 9 a.m., when they next toll. Now the point is, most of the student get confused at what we need to figure out, HCF or LCM. I will say HCF or LCM. You will always confused. I'm not going to tell you any short trick. Just understand. You know, for A, B, C, any, like how many numbers we have, it doesn't matter. If I need to figure out the HCF of those, I know that. HCF of those, I know that HCF is smaller than those numbers. HCF is one of the smallest of those numbers. Okay, I will write down it more perfectly because you will understand. Remember that HCF is smallest, one of the smallest number as compared to LCM. LCM is the greatest one among those numbers. HCF is smallest, LCM is greatest. HCF is smallest, LCM is greatest. That's it. Now, the point is, I have the HCF, ABC, and then LCM I have. Okay, so what I'm going to do, because like when they are ring together, so first they will ring at 12, 15, 18. Okay, first bell will ring 9, 9:12. Second one ring 9:15. Third one ring 9:18. There is no relation because they are not going to follow each other. So what I will do, I will I need to figure out the LCM, because the answer should be greater than ABC, not smaller, because smaller will not work. So that's why we are going to figure out the LCM of 12, 15, and 18. That's the point. So whenever you're reading the question, read that and think about the answer should be greater or smaller. Okay? If it is greater, then obviously LCM. If it is smaller, obviously HCF. Okay, figure out the LCM. 12, 15 and 18. So 3 times, if I will just figure out 12, 15 and 18, I will explain you also, because these are three digits to figure out the LCM. So it's 3 fours are 12, 3 fives and 3 six are. Now you can see 4 5 is not divisible by any of single number, 5 and 6, but 4 and 6 divisible, so I will take 2 here. 2 twos are 5 will written as same as, and 2 threes are 6. 3 twos are 6, 6 twos are 12, 12 fives are 60, 63 are 180. 180 is the LCM, but it is in minute basically. Minute. So convert into hours, it will be 63, 3 hours basically. And 3 hours, so first will ring at 9 a.m., then the next it will ring the same time at 12 noon basically. Understood? Yeah. Now the next one, we have, let's try this one question. What is the smallest number which, when divided by 6, 8, and 12, leaves remainder 5 in each case? This is the confusing question for most of the students, and when if I will ask to any student who is in US, who is studying US curriculum or UK curriculum or any IGCSE curriculum, what they will do, they will prefer the modular arithmetic. But what I told you in the starting, if the student is preferable towards if you prefer, if you prefer that it should be mm, more perfect, more easier way, I will say, I will just recommend that go with HCF LCM. Okay, smallest number which when divided by 6, 8 and 12 leaves remainder 5. I want the smallest number. When I divide the 6 to them, I got remainder 5. When I divide 8 to them, I got remainder 5. When I divide 12 to them, I got remainder 5. So that means these three numbers are divided to a single number. That means that the number that I want is should be greater than these among. So it's obvious I need to figure out the LCM. LCM of 6, 8 and 12. So, so if I will say uh, LCM of 6, 8 and 12 is 24. But I want remainder 5. Now the case is, sir, what I need to do? I need to add 5, or so if I will divide 6, the remainder should be 0. So like 6 divide like 24, remainder 0. That means I need to increase 5 such that the answer should be 5. If I will decrease 5, so it will decrease also. So 24 plus 5, that is 29. Now check that if you will divide these numbers by 29, you will get the remainder 5 in each case. So that's why it is 29. The smallest number is 29. That's it. So that is enough for today. In the next session, in the basic mathematics series, we are going to do enough amount of questions on the HCF and LCM. Okay, so again I'm repeating, if you have any doubt, you can comment on directly. Also, you can visit eduglobalinstitute.com, and there you can just go through our website, what we do and not. Okay, also I will just pin the Google form here on the description box, and anyone who want the one-on-one class with us, just they connect with us. Okay, and from this I'm just ending the session. Okay, have a good day, enjoy yourself, bye.